Today, the Fergalicious 5, Mr. Getty's 6th period class will be taking on the issue and the relationship between mass and force.
Hypothesis. And like people aren't talking about hypothesis instead. So we came up with one. It's if we add weight onto an object, then its acceleration and force will increase. That's it. That's it.
Okay, so for our procedure, we decided to use this plastic car as our experiment here. And so our independent variable, or the one that we're changing, is the weights at the end where the pulley is. And we used 3 different weights, 10, 20, and 30 grams. What we did was we used a stopwatch and we measured over a given time. So for example, we stopped it and it was 0.27 seconds. And we averaged out those times, and that's where we got our calculations for the acceleration. Okay, so our data table shows the grams weights 10, 20, and 30, and the resulting times from 2 separate trials that we'd averaged out with 2 other separate stopwatches. And so here are the results from trial 1 and trial 2, and when we move on to the calculations, we averaged out these times to get our seconds. Okay, so now moving on to the calculations, we decided to find the acceleration. We wanted to use the formula, which is x naught times v naught times t times 1/2 a times t squared, the first formula in Mr. Getty's class. And so we did 1/2 times a times, in this case for 10 grams, 2.74 seconds squared, which is equal to the same distance we used, which is 1.3 meters. We measured it out on the table. And so we did this for the following, for each ones, with the result of getting 0.35 meters per second squared, 0.78 meters per second squared, and 1.2 meters per second squared. We then took these accelerations and put them into Newton's formula, which is mass times acceleration equals net force. And so we multiplied that by the mass of the car, which in this case was 0.255 kilograms, and we got 0.1 newtons, 0.2 newtons for 20 grams, and for 30 grams we got 0.31 newtons. And now on to the graph.
So this is our graph, and it clearly shows that mass and force have a linear relationship with each other. As the weight goes up, the force goes up, and that's basically what this graph shows.
People these days, they don't like to finish things, but we like to finish things. So we came up with the conclusion. It's pretty amazing. And it goes like, therefore, this supports our hypothesis that mass and force have a linear relationship.